Hello all. So in this video we are going to go over Java collections framework. Java collections framework is a similar framework to C++ STL. It offers generic some general algorithms and data structures. So these data structures are common data structures which we will find useful while solving the Leetcode problems. Okay. So we'll go over all the common data structure that it offers, like arrays and linked list, stack, heaps, queues, double-ended queue, min and max heap, map, set, and everything. So let's start. So we'll start with arrays. So this is our arrays example. We'll study about these data structures by writing code and running it and seeing it. Okay, so first thing, so we'll talk about creating a 2D array. So 1D array, I am not going to talk about it because we have discussed that in one of the previous videos. So let's start with a 2D array, and I'm going to take integer 2D array. So this is how you declare a 2D array in Java. Okay, new int, and then you could give it any size, so 3 cross 4 for example. Okay, and then what I'm going to do is I'm going to populate it with some values. So I'm just going to insert some random values equals, let's say I would say I plus j. Okay, and so here I'm doing nothing. I'm just creating, I'm just initializing this 2D array with some values. This is the statement to create a 2D array. Okay, so I'm demonstrating this on integer, but this could be any data type. Okay, so let's see now. Let's try to print all the values. So there are two ways to do it. One is like the normal using two for loops, which I'm not going to write because that is very trivial. So let's see how we can traverse a 2D array using a for each loop. Okay, so this is how we are going to write it. So remember a 2D array being an array of arrays. Okay, so what I'm doing here is, and then I'm just going to print it. Okay, same printing num. Okay, and then here a new line. Okay, so let's try to run it and see. Okay, so this is our output 0 1 2 3 1 2 3. Okay, so how this works is, how this for each loop works. If you have seen my previous video, I've explained how for each loop works basically. So I'm going to briefly describe it here again. So for each loop, the syntax is there is a colon and there is a left part and there is a right part. To the right part is the data structure or the collection which we want to iterate, and to the left of it is the type of data that it contains. Okay, so ARR is our 2D array. So what it contains is 2D array is array of one-dimensional arrays. So that's what this statement means, that I want to traverse each one-dimensional array present in ARR. Okay, now in this internal for each loop, again there is colon, and then there are two parts. To the right side, it's again the collection or the data structure that we want to iterate, and in this case it is A. Okay, our one-dimensional array. And then I'm saying what does this 1D array contains? It contains the integer values, right? So I'm saying for each integer num in array A, I just want to print it out. Okay, so that's how you traverse a 2D array. So whenever you have to traverse, you can write these two statements, and then whatever logic you want to apply, you can apply it inside these two for loops. Okay, so let's see. So that's about how you traverse. So that is it about the 2D arrays. Let's move on to the next topic. Next topic is strings. We'll see how we'll see some common operations on strings and how we can create a string. Okay, so let's create a string first. So string is a class in Java which is pre-built into its library. So I can give it any name and then I can initialize it statically. Hello world. You can put any string here. That's fine. Okay, so the first function that I want to demonstrate is length. Okay, so let's see how we can get the length. So let me try to print it out. So what we would do is, it's simple as you have guessed. We would just do this. Okay, so this is how we get the length of a string. Okay, so it's 12 in this case. Okay, next method is equality check. So how we can compare two strings. Okay, so I'm not going to I'll not go into the details of how strings are managed in Java. We'll just see an example of how they are how the equality check works, like what functions are used. Okay, so there are two types of equality checks. One is like considering the case, and another one is like ignoring the case. I mean uppercase and lowercase letters. Okay, so let's take another string and call it str2, and let's say I do like this. Let me write it like this. Okay, and I want to do str1 dot equal str dot equals okay, str2, and we'll see what does this returns, and I'll just print it out. Okay, so let's run it. So it says false. So the return type for the equals method is boolean, and it says false because these two strings are they have different cases, right? This one is entirely in uppercase and this one is in lowercase. Okay, so this means that equals function is considering the case. I mean, if the case are different, then it would say false. Okay, so what if I want to ignore the case? I have to use this function equals ignore case. Okay, let's see now. So it's true now. Okay, so that's about string comparison. Okay, next is how can we convert this string into a char array. So sometimes in Leetcode problems you might have this situation where you would have to convert this to char array. Okay, so let's see how we can do it. So there is a simple method in Java to do that, and it's called toCharArray. So just toCharArray. Okay, so this is the method and how it can help us. So this is a char array now, and we can use so remember that this is the type. This is how you declare a one-dimensional char array. Okay, so C equals this one. Okay, and how you can now you can traverse the string character by character if you want. So that is one advantage of it. How can you do that? We can again use the for each loop for char C in, or ch in C. What do we want to do? We want to print. Okay, and let's print in every line. So let's see, I'm commenting out this one. Let's run it. So as you can see, hello, and then the space, and then world, everything is getting printed. Each character is getting printed in a separate line. So that's one use of converting it into char array. So obviously I don't need to create this char array for this for each loop to work. I can write it concisely like this. What I can do is I'll skip creating the variable. I would simply do it like this, char ch in str.toCharArray. Okay, so let's run it and see it's working as expected. So yeah, everything is getting printed. Each character is getting printed one by one in separate lines. Okay, let's move on to the next function. Okay, let's first talk about dictionary order comparison. How to compare if to which string comes first in dictionary order or lexicographic order. Okay, how can we do that? So there is a compare to method. So we do that with compare to method. Compare to method does the dictionary order comparison of two strings. So if let's say I have this string a, and then I have this string bb. Okay, so what happens? How can I compare? I would say str dot compare to str2. Okay, and this returns an integer. So what this means is that if str1 is less in dictionary order than str2, then this would return a negative value. So basically this what this is doing, this compare to does is it takes each character of these two strings, str and str2 in this case, and it would do a diff. So it would do in C++ terms, it would do something like this for the first character. Okay, and for each index it would continue doing that until it finds a difference and it returns that difference. If there is no difference, it would return 0. Okay, so let's run it. So -1 since a is smaller. Okay, let's see what happens with this. Okay, so now if I do it, I should see a positive value, right? Because single a is would come first in dictionary order than double a. Okay, so that's about string comparing in dictionary orders. What about this one? What happens? This would return difference again. As I said, this returns the difference. So this is basically like subtracting the ASCII value, right? So small a character has an ASCII value of 97 and the capital A has 65. So this returns a positive value. So how you can write logic if you want to kind of compare these two strings? So you can write if str dot compare to str2 is less than 0. That means this means that str would come first in the dictionary order. Okay, let's see what is the warning here. Yeah, so because we have kind of declared these strings statically, that's why we are getting this warning. So ignore that part. So that's how you compare. So remember, the important point to remember is that the compare to method returns integer values. It's very similar to C++ string comparison. Okay, what if I do not want to do I want to ignore the cases while doing the comparison. Okay, so let's first see what happens. This would return 32, just like the previous example, right? But what if I want to ignore the case and consider the equal and the capital and the lowercase letters as same? So there is a different method. It's called compare to ignore case. So let's run it. So now it's 0. 0 means both the strings are equal. Okay. All right. Moving to the next method, which is char at method. So in Java we cannot directly do like this. So these are our two strings. So what if I want to print what character is present at for example, let's take a bigger string, or let's take our first string, okay, which was hello world. Okay, what if I want to print what character is present at this index, which is the second index 0, 1, 2, right? How can I do that? So in C++, we would just use this as index, right? Like this str2. But this is an error in Java. So if I run this, so I see the error, array required, but string found. So string internally it's a character array, but in Java we cannot use index operators. Okay, so that's why we have to use this function char at, and we would pass the index here. Okay, so now this would work. Okay, so you see this is our output, L at second index. So that was another difference between string in Java and string in C++. The point to remember is we cannot use index operator to access any particular character, okay, in a string. Okay, next is index of. So index of method would return the index of the character that we are looking for. Okay, so what do I mean is index of, and we have to pass a character here. So let's say I passed W. Okay, so it would return the index at which this character is present. Okay, so because we pass the smaller case letter, so that's why it's not able to find. Okay, so because in our string W is in capital, so let's use this. So it's 5, right? What if there are 2 W's? So in that case, if there are multiple characters in the string, then it would return the index of the first occurrence. So we can test that with L. So first occurrence is at 0, 1, 2, so it should return 2. So as you can see, it returns 2 here. Okay. What's next? StringBuilder. Okay. So in Java, sometimes in solving the problems, you might have to create strings by appending characters. Okay. So how we can do that is, like, let's say I created this string, and right now it's empty, and I can say str plus equals any character A. Okay, and let's do it like 3 times. Okay, so this one should append like 3 A's, right? Let's run it. So 3 A's, right? This is one way to create a string by appending characters in Java. Okay, you can also concatenate different strings together. Okay, but that is you can use the same operators, but this operation, like using plus equal to, if you have to append multiple characters or multiple strings together, then this method is quite inefficient. So, and to counter that, to have a better approach, to create a string using if we have to create a string by appending multiple times, we use StringBuilder. Okay, so this is just to optimize things, and this is how you use. So StringBuilder is another class. Okay, and then it could also, like, you can also start with some string. So for example, I want to start with this string. Okay, and then I would say sb.append. Okay, append whatever B. I can give a string, or I can also use a character. Okay, so now, and then how you print it, if I want to see what is the current string represented by sb.toString. Okay, so so you see str, we started with str and then B was appended. Okay, so if you want to use this str, I mean, we have to remove this. Okay, now it would be as expected, AAA and B. Okay, why it is like removing this two string part is like not highlighted in my IDE, because we are trying to print the string builder, right? And if you are using any object inside the println methods or any print method, Java understands that we are trying to print it, and if this object has a toString method, it calls it by default. Okay, so if you see this, the result is same, so I don't need to specifically write toString. Okay, so, and there are like different methods in StringBuilder as well, like comparing to string builder objects and things like that. But you can learn more about it when required. But this is a common use case in Leetcode problems, like where you have to kind of build your string by appending several strings, and then if you use plus equal to, that would like kind of increase the runtime by a lot. So you can in those scenarios you can use string builder to efficiently append multiple times and create a new string and decrease the runtime complexity. Not the complexity, but the decrease the total runtime. Okay. All right. So that's about strings. Let's move on to the next topic. So our next topic is linked list. Okay. We talked about singly linked list, how we can create a singly linked list in one of our previous videos. But in this video, we are going to talk about how to use Java's linked list class. Okay, so Java has a linked list class, which is by default it's a doubly linked list. Okay, so let's start. So let's see how we can create a linked list in Java. So this is the class linked list, and then what we have to do is we have to pass the type of data that it would contain. Okay, so let's say for example in our case we have to pass integer, and rest of the things are same, new linked list, just like that. Okay, so this would create an empty linked list. Okay, you must have noticed I have used this integer class instead of like simply writing like this. Okay, if I try to use primitive type, this throws me an error. Okay, and what is the error? Let's see what the error is. It says that linked list expects of type object, but it's integer. So you don't have to think about this error too much at this point. The only important point for you to note is that it won't work on primitive types. You have to use objects. In Java, every primitive type has a corresponding object. Okay, so int has a class of integer. Okay, so float has a float, double has a double, and so on. So whenever you have to use Java's linked list or any other collection framework, that should be an object, okay, not a primitive type. Okay, so let's see now. So that's how I would create an empty linked list. Okay, let's add few values here. Okay, so I would say 0 I less than 10. I'm just trying to add few values to the linked list. Okay, so let's say I'm just trying to add I. So whatever is the index value, I'm just adding, and now I want to print. To print, I can again use the for each loop. And what we have to do to use the for each loop, same thing, right? There is a colon, and then there is a right side, which on the right side is the type of collection. Okay, and to the left is the type of data that we want. So we can use this int and num, okay, in LL. And then what we can do is print. We don't want to print in separate lines, so I would just use the print. Okay, let's see. I'm trying to run it. So this print, this is our linked list. Okay, so what you saw, add would add a new node to the end of the list, right? Okay, so that's how you append a node to a linked list. Okay, so we saw creation and we saw traversal, okay, using for each. How can you do a reverse traversal? Like if I want to go from 9 to 0, from last node to first node. So to do that, we have to use something called as reverse iterator. Okay, an iterator is again it's a separate topic for discussion, but for the sake of this video, just have to just stick with the fact that iterator is something which enables iteration in a collection. Okay, so similar to an iterator, there is a reverse iterator. Okay, let's see how we can do that. So to do that, we have to use something called as descending iterator. Okay, and this is of type iterator, of type integer. Okay, so how, like, we have to take it in some variable, right? So what I would do is iterator of type integer, and I'm calling it I. Okay, I, and how, this is the check has next. Okay, so has next checks if there are more nodes to traverse in a list. Okay, and then what I'm going to do is just going to say I dot next. This is how you access the value present pointed by the iterator currently. Okay. Yeah, then the space, and let's see, let's try to run it. Okay, so we used, this is not a pretty output. Let's do that again. So 987654. So this is traversing the linked list in reverse. Okay, so a little bit more about these methods. So you have to initialize the iterator and then you have to move it, right? So this is how you initialize a backwards going iterator. LL is our linked list object, like this object contains the linked list points, and then we are using descending iterator function to get a reverse iterator object. Okay, and which we are collecting it in iterator of integer type. Okay, now there are two methods, has next and next. Okay, has next checks if there is still a new node present which has not been traversed. Okay, it checks like that, and then I dot next, what it would do is it would print the value present pointed by the iterator presently. Okay, so you can think of it like this. It just checks. So if you try to visualize it, you can say that has next, the iterator points not to the current object. I mean, so to start with, it won't point to the node containing 9, but it's pointing something like before 9. Okay, and then it says, does it have a new node? So there is, yeah, if the answer is yes, then it would go to the next node and then it prints. Okay, so I dot next, which prints 9, and then it positioned between 9 and 8. Okay, so this is how you can visualize an iterator. So this is my linked list. Okay, which is 0, 1, 2, 3, 4, 5. I'm just taking 6 nodes here. Okay, when you create an iterator, it is not, let's say, just assume that it's not pointing to the object. So in our case, in the example that we saw, we were using reverse iterator, right? So you can say that reverse iterator, when we initialize, it points somewhere here. Okay, and also remember that Java is a two-dimensional. The linked list is like the doubly linked list, right? So it would have arrays going backwards as well, which the iterator would use. Okay, and this is the head of the linked list. Okay, all right, here it points to null. Okay, okay, so again, going back to the iterator, when we initialize the iterator, a reverse iterator, it is positioned here, and then when we say, what is the syntax to check if there are no nodes present? So we say I dot has next. So here it's, since it's a reverse iterator, it would go backwards, and then it sees, yeah, so from here it sees that, yeah, there is a next node present. Okay, and then what is the logic to print it? I dot next. So what I dot next would do is, I dot next would print this value and then move this iterator again to between 5 and 4 nodes. So the important point that I want to mention here is, like, if you want to visualize how iterator works, so don't think of them as pointers who point to the nodes, but you can think of them as in between nodes, adding a node in front of the list. Okay, so how can we add a node in front of the linked list? So linked list has a method ll.linkedlist.add first. So you might have seen. Okay, so if I do this, this would become my first node. Okay, and let's print it. So I would use for each. Let's run it. So as you can see, 10 became the first node. Okay, and similar to add first, we can add a node at any index if we want in the linked list. Okay, so add first is like adding at 0th index. So what we can do is, let's say I want to insert at the 5th position. Okay, so add. So it's the same method, just have to pass the first argument is index and the second argument is the value that we want to insert. So run it. Okay, so now you see it got inserted after the 5th index, right? So if you want to insert in the end, what you can do is, there are two ways to do it. If you want to kind of add a new node at the end of the linked list, what you have to do is this called add last. Okay, and we can also use use the index. How can I say how to add in the end? So I would say ll.size, like add at that index. Okay, what happens if I like pass an index which is not present? So ll.size plus 3. Okay, what happens? So it throws an exception. Okay, index out of bounds, just like in an array. Okay, so that's about it. So linked list is it's not fixed size data structure. As you keep on adding the nodes, the size of the linked list would keep growing on. Okay, adding a node at the end, we saw this. Removing a node at index. So how can we remove a node present at any index? So see, this is our linked list, and then how can I remove? ll.remove. Okay, remove, let's say I want to remove from head. Okay, so I would say ll.0, and then let's print it again. Okay, so let's run it. You see, this was our original list, 0, 1, 2 till 9, and then I removed the node at present at 0 value. So the list is now starting from 1. Okay, we can pass any index, for example 4. Okay, so this would, so this was our original list again, and then this removed the value present at 4th index. So 0, 1, 2, 3, 4, it removed 4, and then this is our list. Okay, we also saw how to get the size, the number of nodes in the list, using the size function. Okay, similar to the descending iterator, we also have like a forward going iterator, and which is being used internally in the for each loop. So whenever we are this is a shorthand for, like, you can say using a forward going iterator for any collection. Okay, so yeah, that's about it. And the concept that we learned, that iterator points to between the nodes, that would hold for the forward going iterator as well. So it also has these methods like has next and next. Let's see if we can use that also to print print out the list. Let's try to use it here. So list dot iterate, ll dot iterator. Okay, so if I just use iterator, it would give me a forward going iterator, and it would be of type integer. Okay, I, and then what I would do, I want to iterate till it has some nodes. And you remember, like, if we use normal, like using indexing, I could have done plus I, but I'm not printing it like that. What I'm doing here is print, and then I would print I dot next, as we discussed. Okay, so this would essentially do the same thing for me. So this printed the value in the forward, like from head to the end. So if you want to avoid doing like all this code, you can just use for each loop, which internally uses the forward iterators only. Okay, all right, so that is all about the linked list methods. Let's move on to the next topic. So our next topic is stacks. How how can we use Java collection stack? So the class that we want to use if we want to create stack is stack. Okay, and again this would want an argument from us as what type of stack do we want, and again we cannot use primitive types because for the same reason it would because these types expect objects. Okay, so stack of integer, and let's name it s, and then it's very similar, the syntax is very similar. And then what we want to do is we want to see how we can push, pop, peek, and then traverse the stack. So let's try to push some values. Let's use a loop only for so here I am creating a stack and I'm pushing the indexes onto the stack. Okay, let's traverse and see what does the stack contains. Okay, so we can traverse it without popping out the values. So we can use, again we'll use the for each loop, again going by the same logic, int n colon s is our stack, say n. Okay, let's see what is the content of the stack. So 0 1 2 3 4. Okay, so we can traverse it. This is our current content. Now what we want to do is, let's say we want to push one more value, so it would go. Okay, so this is like a normal sequential traversal. Let's say I want to pop a value. Okay, so I would say .pop. Okay, and then I want to see my stack again. So what value it would have popped? So we are inserting 0 1 2 3 4. So 4 is our topmost value, so 4 should not be present after the pop, right? So let's see. Okay, so yeah, 4 is not there. It's just that the output is like not very much readable. Okay, let's see now. So here it is. This was our original stack, and now 0 1 2 3. So 4 popped out. Okay. If we want to also access the value that is popped out, we can simply so pop also returns the value that is being popped out of the stack. So we can simply do like this. Okay. I'm removing the last print statement. So commenting out this one. So let's see now what it prints. It just prints 4. Okay, and we can do it one more time, and then it would print 3. Right? So that's why. Peek. Next method is peek. Peek won't pop the element, but it would just show what is the topmost value of the stack. Okay. So I would do s.peek, and it wouldn't pop. Right, so for the first statement it would just access, it would just give us the topmost value, and then in the last statement it would again pop the same value. So both of these print statements should be printing the same value, which is 4. Okay, so these are the common stack methods. Again, how we can check if a stack is empty or not. So what we can do is, again we can use the is empty or size method. So we can say if s dot is empty, then let's say we want to print empty. So this would return a boolean value. Is empty returns boolean. If the stack is empty, it would return empty. It would return true. Otherwise, it would return false. Okay, so else let's print not empty. Okay, let's run it. So not empty, right? Let's remove these two statements, which is fine. We can also use size, which gives us the total number of elements present in the stack. So you can also do something like this, greater than 0. Then that means like there are few elements present, and then in that case it's not empty. Okay, so I would do like this. If the size is 0, then that means it's empty. Otherwise, it's not empty. So not empty, right? So those two methods also you can use to kind of know about the size or check if a stack is empty or not. So size and is empty is like kind of you can access it through every data structure in Java. So these are the common methods in the collections framework. That is it for stack. Let's move on to the next topic. Next topic is queue. Let's first create a queue. So we would do something like this. Queue of, again we can use any other data type which is an object. So if you want to, let's say, use an integer, we can use integer object type. Okay, so we have seen examples with integers, so I want to use something else. So let's say I want to create a string queue. Okay, queue of strings. Okay, new linked list, and that's how you create you cannot do a new queue, so you have to keep that in mind. I'm not going into the details of why not queue, because you cannot initialize on a queue type. Okay, so that is some Java detail, but I don't want to go into that. So if you want to initialize a queue, create a queue, you would write something like this: queue is equal to new linked list. Okay, and then what are the queue operations? We will enqueue some things, or offer, poll, and then dequeue. Okay, and then in the end there would be like again size and empty checks. So let's first see how we can add values to the queue. So it's simple. You can use this method queue.offer. There's a little bit of difference between offer and add. For our purpose, there is no difference. One of them throws exception, one of them returns like the special value, for example. Okay, in case of failure, it's just about what they return in when the operation fails. So let's only use offer. Offer would use like it would return true if the operation succeeds and false if there is a failure. If you want to see this, I can open this Java documentation. You can see it says it returns true if the element was added to this queue, else it returns false. Okay, let's go back. These are our queue contents. Okay, so that's how we add values to the queue. Now let's say we want to see what is on the top of the queue. Okay, so what is the first value that can be accessed in this queue? So what we can do is we can peek. So do queue.peek. So what it should be, we are doing offer 3 times. First it's hello, and then hey, and then hi. So queue is first come first serve, so it should be hello, right? So as you can see, printed hello. So peek does not remove the elements. So if I want to kind of consume the remove from the queue, what we can do is poll. Okay, so queue.poll. Okay, and if I'm doing it again, you could see the different strings. So hey, which was the once. Okay, I am again doing this peek. Yeah, so I did a poll, queue.poll, which removed hello from my queue, and then the next string is peek. Okay, so poll also returns whatever value it polled or removed from the queue. So you can use that directly here if you want. Okay, so hello, this was our peek. Peek does not remove the value, so still hello was the first element to be removed. So when we do queue.poll, it removed hello. Okay, again similar to a stack, you can do size or empty checks. Okay, similar to that. Those methods are very similar to stack. So you can do things like this: queue.isEmpty, then same thing, we can do any operation. Okay, so I'm not going to write it, it's fine. I think that's understandable. That's it about queue. So you can use any other data type if you want. Okay, any other integer or float, double, whatever. Okay, so that's how a queue would work. So that's it about the queue. So that's it for this video. In the next video, we would talk about maps, sets, deck, and then some common algorithms like sorting and searching. So stay tuned and thanks for watching.